Now I would like to explain the bending test on simply supported beam. It is a simply supported beam. We are going to have bending stiffness. We are comparing with practical and theoretical. It is the length of the beam we are going to have it. Maybe the length you can take it 1 meter or 950 mm. So this point, the distance between the 2 points we have to consider. It is a rectangular cross section beam, and the dimensions are 25 is the breadth and 12 is the depth. So for moment of inertia I am saying it is BDQ by 12, of course. Then it is the span where we are providing the loads. Of course its weight also we are considering. It is a dial gauge. We can measure with this 10 mm deflection. So now the things what we require according to the formula as well as practically is the moment of inertia we want, the length of the beam we want, Young's modulus we want, load and deflections. These are the things we require to have. So how we have to do it? So when we are having the beam like this, when we are providing the load here, we are going to have the maximum deflection in this middle. So we know in simply supported formula, deflection delta is equivalent to WL by 48 EA. Here we are having lesser deflection than cantilever beam, of course, we know it. Now, the values how we are going to have it is a no load. We set the dial gauge for this, so make it 0. No readings, no need to calculate. You set any errors are there, set the dial gauge for that. Now we are going to have the load. First load, you take this as the first load. It is 750 grams, 0.75 kg. Convert this 0.75 kg into newtons. So that what we have to do, multiply with 9.81. This is the first reading. Then add in the span 2 kg. So what is the total load? 2 kg, this is 0.75, 2.75 kg, second reading. Then further we have to have what is the deflection it is going to have it. So you have the reading and you put it in a table. Then next load you add on, go on adding 2 more kg. So next reading is 2.75 kg is over as the first second reading. Add third reading 2 more kg. Then it is 4.75 kg. Then take the reading. Then add 2 more kg. It is 6.75 kg. So take the reading. Then add 2 more kg. It becomes 8.75 kg. Now the reading. Then 10.75 kg when you are adding 2 more kg. So these are all in terms of kgs. You have to convert these loads into loads in kgs into newtons by multiplying this value into 9.8. This is how we have to have the readings from this equipment. Then we are moving to this board for the calculation. Now I am explaining about the calculation part of the simply supported beam. Here what are the things we have to have it in the table. The first serial number I am writing because we are going to have 6 readings. I am writing 6. Then length of the beam. Length of the beam, whatever the length of the beam we are taking, maybe 900 mm, 950 mm, write it for all the calculations. It is common for all the calculations. Then Young's modulus for the steel beam, it is steel beam. Its value is 2 into 10 to the power of 5 Newton per mm square. I am writing here. Then moment of inertia, because we know the B value and D value. B value is 25 mm, D value is 12 mm. So I is equal to BD cube by 12. So we are going to have moment of inertia in terms of mm to the power of 4. Then load. Now we are having the first load. It is 0.75 kg. In terms of newton, multiply that 9.8. Whatever the deflection, we are getting right there. Now to have the stiffness, what we have to do is, so it is load. It is load. Sorry, it is W. It is W. So it is W. It is delta. So what is this? Please see it. It is not L. I will write it a little bit. I am writing it. Please see here. So it is load is W. Load is capital W in Newton. Delta is in mm. So the cable stiffness is W by delta. We are getting it is Newton, it is mm. Newton for mm. It is stiffness practically. We are getting from the equipment. Experiment. So stiffness theoretically. It is theoretically the formula is. See it how I am writing. Formula theoretically is 48 EI by LP. 48 EI Young's modulus into modulus of this one moment of inertia by length of the beam Q. So now we wanted to have the error. What you have to do is, let us say it is the first value. It is first value. The first reading, first value practically. Second value is theoretically. We have to do here 1 minus 2 by 1 into 100. Like this we have to take it. Sometimes we are knowing we are getting an error here, like some value where you are taking this negative value you are getting. At that time you take it 2 minus 1 by 2 into 100. You make it like that. See that some positive value you are getting. For all 6 readings you have to get the values. So make the average of all the 6 values. So that becomes the error between stiffness practical and stiffness theoretical. This is how we have to do bending test or simply supported beam.